In this video, we'll learn how to program in C#. We're going to get it set up and running on your local computer so you can follow along. Whether you're brand new or just need a quick refresher, this roughly 30-minute course is designed to expose you to the fundamentals of C#. During the video, I recommend that you either speed me up by using the settings playback feature or slow me down if I go a bit too fast. It's also recommended to use an AI like ChatGPT on subjects you have more questions on, or feel free to reach out with a comment. All of the links, including the source code used for this course, are in the description, so let's get started. Before we start the install process, we'll need to install our prerequisites if we don't already have them installed. The first one will be .NET 7 SDK, and the other will be the VS Code editor. Links for all these products will be in the description below. During the install process, you'll just want to follow all of the default prompts for both products. When you have both products installed, you can check the .NET version from a command line prompt by typing .NET-version. Once this checks out, we should be ready to go. Okay, now that you've installed VS Code, you should see an application similar to what you see on the screen now. Now, to enhance Visual Studio Code, we need to install a couple of additional extensions, and the first one is going to be C# Dev Kit, and you'll want to type that in the search bar and hit enter. Once you see it, you can select it, and you should be able to install it. I've already installed mine, but you'll just want to click the install button right here. When you install this, it will also install the IntelliCode for C# Dev Kit. You can uninstall that one if you want, but I recommend keeping it. One other recommendation that you'll want to install is another C# extension by Microsoft just called C#. This one you'll also want to install as well. Once you have both these set up, we should be ready to go. Now that we have everything installed, we want to go ahead and set up our project, and we can do that by clicking on the Explore button and then clicking on the Create.NET project. Then we'll want to go ahead and choose the console app. Next, we should see a dialog that will ask us where we want to store our project. I'm going to go ahead and create mine in a folder called Projects, and then I'm going to select that folder. Once this is done, it'll ask us what we want to give the name. I'm going to call it Learn CS, and then hit enter. Now Visual Studio Code has set up our solution, and we should be ready to start programming. Okay, so let's dive right in and see if we can get this working. We're going to open up the Learn CSS folder, and then we're going to click on this program.cs file. Now, you'll see that it says Hello World, but just to make sure that it's everything that we want it to be, we'll say Hello World from C#. And then we're going to come over here to the right-hand side of the screen, and we'll click on this little drop-down, the chevron drop-down, and click Run associated with this file. What this does is this compiles the program, and then it runs the program that's written here, and it says Hello World from C#. So now we should have everything working and ready to go. Now let's go ahead and go into just a little bit of detail of what happened when we created our project. You'll notice here that there's two folders. The first one is called bin, and the other one is called obj. The bin is what is created for all of the files. When you compile it, it will create the DLLs and the executables and everything used to run the program. All of that is stored in the bin directory. Additional artifacts and configuration files will be stored in this obj directory, short for object. Now, in most cases, you won't be messing with those, but it's just some context for what you need to know about the particular project. The next one is called a CS_proj file. Now, this file is just used to house all the different files that you'll be adding to this project. And if you create larger programs and you have multiple projects, you're going to see this SLN file, which actually houses everything for multiple projects. But for the case of this one, we'll just be using a regular project file. Okay, so let's start looking at a little bit of code here. This first line that you see on line 1, they're making a comment about how the information has changed. And if you've ever worked with C# before, or maybe came from Java, then you might be used to something called a static main, and that is usually the point at which a program would enter. And as .NET's evolved, they have this new feature that allows you to skip doing the static main. So if you want more information about that, just visit the link up there and they'll give you all the details. But just know that you can start your program.cs file just plain vanilla, however you want. So the first thing that we're going to really cover here are comments, and I'm going to go ahead and paste some in here. Comments are pretty straightforward in C#. They're either denoted with a // or you can do a / with a */. And these are just single line comments, meaning that you can just put one line per here. And this one means that you can put as many things as you want inside of this comment. So this is just a way to get started by looking at comments. So at the heart of every programming language are variables, and here are the main variables available in C#. Now I've listed all of the primitive types, excluding just a couple. I don't see float in here, but this covers most of them. And it is notable to note that string is really not a primitive type. It's more of a reference type, but we'll cover that a little bit later on. But really at the heart of variables, a string is there, so we're going to go ahead and cover it in here. Now, if you hover over each one of these, it'll kind of give you a real definition of what each one is. But for most parts, there's byte, there's int, which is integer, there's double, which is decimal type, there's boolean, there's char, there's string. And this is just kind of a high level. If you want to check the manual, they have every exact type that you want, but this covers most of them. And the thing to remember with variables is that they are really the key piece to every programming language because it's how you store and move data. So let's go ahead and run this real quick and just see what the output is on each one of these. So there you go. In our string, we're just outputting each one of these types. Now, one thing to note too is that, at least in my career as a programmer, most of these you'll use quite a bit. It's not rare. It's rare that you actually do use the byte a whole lot, but it just depends on what you're programming. So that is a quick overview of variables. So another key feature to the C# language are what we call operators. I have some samples here. There are considerable more amount of operators that are available, but we'll just go through some of them right now. Operators are great for performing operations. They help you manipulate data. They're great for comparing values. They're used for assignment. Without them, you couldn't assign a variable. You use them in control flow, type conversion, bit manipulation, and so forth and so on. So operators are, very important in the C# language. Some of the first set of operators we have here are arithmetic. Obviously, you have, adding a number together, subtracting, multiplying. The other one is the very important, what we said earlier, is assignment. And in C# you can also assign a variable. So you might assign the value to 10, and then you can assign another variable to that variable. And then you have plus equals and minus equals, which is just adding and subtracting the values. Then you have comparison operators. So with operators, you can do so many different things. We'll just go ahead and run this here real quick just to see what our output is here on all these. And as you can see, it ran through each one of these. But the best place to get started with operators in C# is obviously to drop to the C# manual, and you can see all of them. But operators are extremely important in your programming with C#, and you'll definitely want to get familiar with all of them. All right, so moving on, you'll notice that I commented all the code above just to kind of keep things clean. And the next thing we're going to cover is something called structs. And I'll paste a sample in here. And before we dive too deep into the struct, I want to backtrack just a little bit here. Remember at the top of the program where I talked about a class with program and something called the static main. That's how you enter the program, and how C# has advanced and you don't have to do that anymore. Well, I went ahead and brought that back, just one as an example, and two, it kind of helps me kind of keep this code a little bit more organized. But moving on, let's talk about what a struct is. So a struct is it's a better way for you to help to improve the organization of your data. So take, for example, up here, if we had two integer values and we wanted to say point X and point Y and assign them to a value, that can get kind of messy because now we've got to start remembering all these different variable types. But if you break it up into a struct, it allows you to create subpoints, and you'll see down here where you create this new object and you have an X and a Y. So a struct is, in addition to the primitive types, it allows you to define your own values. And they're similar to classes, which we'll cover a little bit later on, but they're more of a value type than a reference type. And what that is just a fancy way of saying that they're managed in memory a little bit differently. But you can see an example of a struct here. And you declare a struct by using the new keyword. So you'll say, hey, I have a point and I want to create my new point. And then you're going to assign it a couple values. So let's go ahead and run this program just to see what we get on the output. And you'll see here. And so just like we outputted variables, the struct does pretty much the same thing. You can output these variables. So this is just kind of a high overview of what a struct is. If you really wanted to dig deep into structs, you can actually check out the manual. In my programming career, we use them periodically, but we typically use classes significantly more, which we'll cover in just a little bit. So that's a high overview of structs. Okay, so the next thing that we're going to be covering in this section is reference types. And reference types store references or memory addresses to objects in memory rather than the actual data. And it's just a better way for the C# language to better manage memory. And the main reference types that we'll be covering today are classes, interfaces, delegates, arrays, and strings. Even though we covered strings a little bit up there, it is considered a reference type. So we won't dive deep into that, but just know that the string in the programming world of C# is considered a reference type. So the best way to get started with understanding what classes are and how they work in C# is with an example. Think of a class as essentially a blueprint. It's a blueprint for how something is going to interact in the real world. And with this example here, we have a person class, and we're delegating a name and an age to this person, and we're going to give an action to this person, or what we call a method, and that person is going to say hello. And so the way that you construct a person class is through this new keyword. And so say we wanted to create a new person, we're just going to say person 1. We wanted to give her the name Alice, and her age is 30, and then she wants to say hello. So if we run through this program here real quick, we can see that it outputted. The whole piece to take away from this is that you can construct these classes any way that you want. They're very dynamic in that fashion. And as you use C# as a language, you'll find out that there's just a lot of things that you can do with a class object. But not to go into too much more detail, that is kind of a high level of how a class works in C#. Okay, so we covered the main blueprint of a class, but let's go ahead and dive in just a little bit deeper and see what we can do with a class, and mainly the whole reason of why we have these classes. So say we wanted a new person, and we wanted to create a new person object, and we're going to call this person2, and we'll edit that out. And so this new person2 is going to have a name of, and do notice that when you do set a string, you have to use the double quotes and not the single quote. It's just a quick pointer on that. And so now you can see the reusability of this. So the main thing, if you're new to programming and you're just starting out, the key features of the class is that you don't have to keep redefining this over and over again. So the whole purpose of this new keyword is to reinstantiate this object. And so I keep creating new versions. And that's the whole premise behind a class. And so just a quick example there. And something else that you might also see in here is that you see these, what they're called access modifiers. And so if I change, there's several different ways that you can do this. You can call public. That means that everything that uses this class is available. But if I change this, there's another level called private, then this would not be accessible in here. If you create a variable that's private, it's only available within the context of this class. You can't reuse age outside of the class. So that's just something to keep in mind. And there's also protected levels, and this has to do with when you're starting to use deeper levels of classes. We're not going to go into this, all of the access modifiers right now, but just understand that in C# there are several different access modifiers. And something else to note is that when you're creating these different methods, you can create several different method types. And this just helps you to really organize and clean up your code. So as you start using classes, and if you've done it in other programming languages, then you know, and you can kind of move past this. But if you are new, then understanding and using the class and getting your head wrapped around this concept is really important. Okay, so the next reference type that we're going to cover here is an interface. And interfaces just allow our programs to follow more stringent rules, and they're usually applied to classes. And as you can see here, we have a great example of a class called circle, and we are applying an interface to this circle. So the way that this really works is it says that if I have an interface called iDrawable, then the draw method must be enforced inside of this circle. So if I was to add, say, another signature here called foo, now you'll see that this is actually failing because I would need to come down here and I would need to add a similar foo method for this to go away. Essentially what interfaces do is they enforce contracts, and as you get into larger programs, they're very essential to creating your applications, and just know that it's another arsenal and a tool that you use when using C#. So moving on in the C# language with reference types, we are going to be talking about delegates. But before we dive too deep into a delegate, let's talk about functions. In case you're new to programming and you're still kind of picking all this up, let's dive real quick into what a function is. You saw one earlier in the person class. Say hello in this class is considered a function, and a function is just a way for you to group code. Now you can do additional things with functions like pass parameters to them. So you could declare a type of string and say it was from, person A, and then inside of here you wanted to pass more data. So this one here, you say person A could have been me, and we wanted to make sure that this person, hello, my name is, Alice, and I'm 30 years old from Corey, because I passed Corey. And so you can see that functions allow you to pass values into them. So without going into a whole lot of detail, that kind of covers the high level overview of what a function is. I would say if you don't quite know what a function is, there's tons of videos online and you can jump in and dig deeper into them. But as far as getting a hold of those in the language, it should kind of give you a high overview of what one is. So let's go ahead and comment this out. And let's jump back down to the delegate. And the reason why I talked about the function earlier is because a delegate is a function pointer. And because it's a function pointer, you kind of had to have that idea and that whole backing ahead of time. So the way that a delegate is created is you use the delegate keyword and you give it the signature. So this should be the signature of what you wanted the method to look like. And then you declare a variable. And because this was declared as this particular delegate called myDelegate, you just declare it as this particular type. And then you set it to another function. So this right here is a function. This is the delegate, and this is just a pointer to that function. So if we were to run this, it should just show us hello from delegate. So what we have here is just a function pointer, and this is a quick example. If you don't quite understand the delegate, you just kind of have to look at it for a while and kind of play with it. But once you kind of look at how things are pointing, they usually fall right in place. So that is a high-level overview of a delegate in C#. The last reference type that we're going to be covering are arrays, and arrays allow you to store all kinds of data. And every programming language has an array. If there is a language out there that doesn't have one, leave something in the comments. I would love to know what language does not use arrays. In this example, what we got here is just an integer array, and you define it by the double brackets to let it know that it's an array type. And this is the actual type of values that it's going to hold. And then you give it the variable name. And then you put your values that you want to store in the array in curly brackets. And if we run through this, we'll see exactly what's happening here. And we'll be covering loops in a little bit. If you're not familiar with loops, all they do is they iterate over these values of arrays. And so you can see that it's logging to the console 1, 2, 3, 4, 5. It's just going through that array really quickly. So you can store an array as many different types. Let's go ahead and create a string array. And if we wanted to change this, we have to make sure that our loop supports a string. And then we're going to just say strings in strings, and then we want to output S. And in this case, we would just get two values. We would just get test and foo, because we're only going to store those two values in the array. So arrays are essential to the programming language, and you can kind of see how they're defined in C#. And I hope that gives you guys a good idea of how C# handles arrays. So moving on, we're going to talk about control structures. And because this video is a quick video, we're just going to be covering the if and switch control structures in C#. There are some other ones with ternaries that you can do, but for this one, we're just going to cover the main used control structures. And so if works similar to every other programming language, and in C#, you have the ability to do an if, an else if, and then an else, and you can conchain multiple else ifs together. So in this one, if I wanted multiple else ifs, I could add, 3 or 4 different else ifs in here. If I wanted to do else if number equals 51, 52, however we wanted to do this. But the control structures simply allow you to execute a section of code. So in this particular case, we're going to check to see if our number is greater than 50, but 42 is not greater than 50, so then it would fall down into this next loop, and it says else if the number is 50, but it's not 50, so we know for sure that the number that it would run through would be echoing out this particular line. And control structures just give you a way to really enhance your program, and without them you would have programs that couldn't do a whole lot really. So the if-else statement is essential to the C# language and to any other programming language for that. You can also do other additional things within, we talked about operators earlier. You could also say, or number, say you wanted to say if the number was greater than 49. You could also do something like this, and the OR operator says that if either one of these values is true, then it drops into this control structure. You can also use and, which means both of these conditions have to be true in order for you to fall into this control structure. So this should be just a quick overview of how the if statement works. And if you jump around and play with these tutorials, you'll find out how they work pretty quickly. So the next control structure that we're going to look is the switch statement. And as you can see, I've already ran this program, and you can see that it's outputting Wednesday. And the way that the switch statement works is it evaluates the value that is given to the switch. So we set day of week equal to 3, and then what happens is the compiler comes in here and it starts looking through each one of these cases. And it says, is the day of week 3? Nope. The first one is case 1. Is 3 1? No. Is 2 3? No. But is 3 3? Yes. So once it hits this, it sets the value and it hits a breakpoint, which means that it exits through this switch statement and comes down here. So if we change this to say 5 and ran it, it's going to go all the way down and it's going to get to our favorite day of the week, Friday, right? What happens if we assign this to a value that is really high and run this? We can see that it's the weekend. So what happens is this default is the very last chain in the command. And if none of these values equal 15, then it just automatically sets the default. So switch, they're very simple to use. Once you play with them, you kind of get how they work. And that is a switch statement in C#. Okay, so the last section we're going to be covering here are loops. And in this particular case, we're going to be running through the for while, do while, and for each. And then we'll cover continue and break really quickly. So the for loop has 3 different expressions in it. And if you look at this first section, int I equals 0, what that means is you're just declaring that variable and you're setting it to 0. The second expression, I is less than 5, is the expression that as long as that's true, the loop will continue to run. And then the last expression, I++, which is an operator on the I, will increment that I. So it'll start off at 0 and then go to 5. And then once that expression turns false, the loop will exit. Now the next one is the while loop, and that we'll look at the expression of what's inside, and as long as that one is true, it will continue to run. And then the do loop is a little bit differently because it will always execute the first cycle, and then while that is true at the bottom, it will continue to run. While it's true, it'll run, but once it hits false, then it will exit the loop as well. And then a for each loop is just a way for you to iterate over an array, and you can do much more complex objects as long as that object has that enumerable interface, the interfaces we talked about earlier. You can loop over those type of objects, but we're not going to go into that in this particular course. This is a high level course, just getting the primers for all of this stuff, so we won't cover that here. And then the last section that we're looking at here is the for loop with a continue and a break in it. So the way that the continue works is if you have, so in this particular example, we have an if I equals 2, then we want to just continue going through the loop. Now if it says if I equals 4, then we want to break out of that loop. Well, if the loop was going to go for 5 iterations, we hit the second if condition there, then it wouldn't finish. And in the case of I equals 2, it won't continue to execute the last part of that if statement. So when I does equal 2, it says continue. The if I equals 4 will never be executed. So there are certain times where you'll want to use these continues and breaks in your loop. They help continue to solidify the loop and make sure that the logic that you need in there can be executed and ran correctly. So this covers most of all the loops. We'll go ahead and run this code just so you can kind of see the output. And I would highly suggest downloading this code. You can get it all on GitHub. It's all available in the description below. And you can run through all of these examples and kind of see what they're doing. So as you can see, this first loop, it just runs through the iteration of all 5. The next one just runs through an iteration of 3. And then the do while loop ran through 5, and it just did a countdown of 5 all the way to 1. And then we did the for each, which was the 1 through 5. And then we using the break and continue, you can see where it skipped certain parts of that loop. So if you grab this code online, you can just run it and you should be able to see how all of these loops work. And that should cover most of the loops for C#. So as we start to wrap up this video, a couple of the things I would like to show you really quickly. The first one here is Visual Studio Community Edition. Now, apart from what we use with Visual Studio Code, this is a very advanced IDE. So if you really want to get serious with C#, I would recommend getting this. It's a free download. It has tons of functionality built into it. You can build Windows applications with it, even Linux and Mac type applications. It's full featured and very rich. So I would definitely check out the link for this. Also, if you want to get the notes for all the program code that we use, you can come up here to gridlife.io and click on the Learn link. This will take you to a page that you can click on articles, and then you should see Learn C# in 30 minutes, or you can just search for it. So once you get this downloaded, then you can download all the links that are in the show notes and a copy of the code. I hope you enjoyed this video on C#. If you have any other questions, leave them in the comments below. If you like this video, please consider leaving a thumbs up, and if you have a chance, check us out on gridlife.io, and we'll see you in the next video.